Hi everyone, in this video we're going to work on going backwards. So looking at a graph and trying to write the equation. Let's see, I think I'm going to zoom in on this one a little bit for you guys. I don't need tons of work room. Okay, so we are given just a little bit of information. We know, my grid didn't copy very well, but what we're supposed to be able to see here is that we have a minimum at negative pi over 6, negative 6. And then we have a maximum at, let's see, we'll have to count them out. That's a pi over 6, 2 pi over 6, 3 pi over 6. So this is pi over 2, negative 1. Okay, so we know where one maximum and one minimum are. We could figure out equilibrium from that if we wanted to. It should be right in the middle, so it should be at this in 2 tick marks at the pi over 6. Okay, so that's not bad info. And we can also figure out the y value of our equilibrium point by saying, okay, if the bottom's at negative 6 and the top's at negative 1, that's a total height of 5, which means the amplitude is 2.5. So from here, if we go down 2.5, we get negative 3.5. And then just to check it from there, if we go down 2.5, 3, 4, 5, 5, 6, it gets negative 6. So that seems good. Okay, so we're supposed to write two equations, one using sine and one using cosine. And there's going to be multiple correct answers in this. There's different ways to shift to line things up. So I'll just give you one example. We just said that the amplitude was 2.5, which means whether we're using sine or cosine, we need to do vertical stretch by 2.5. Otherwise, it's only going to go up and down 1. We also know that our equilibrium is at negative 3.5. So again, for either one of these, you need to shift down 3.5 so that that's your middle. And then we need to do some horizontal work. So we blocked out all the vertical stuff nicely, but we need some horizontal stuff. So for one thing, I can tell that from negative pi over 6 to pi over 2, I go from minimum to maximum. So that's half a period. But this is a fairly nice messy one. We have to actually count these out. So the tick marks are pi over 6s. So I see 1, 2, 3, 4 pi over 6s, which is the same as 2 pi over 3. But that's only half of my period. So my full period must be 4 pi over 3. If it takes you 2 pi over 3 to get from the minimum to the maximum, it'll take you another 2 pi over 3 to get back to minimum, which is a grand total of 4 pi over 3. Okay, period's always the messy one. If period is 4 pi over 3, our coefficient has to be 2 pi divided by that, which is the same as 2 pi multiplied by 3 over 4 pi. And conveniently, the pi's cancel, and even a 2 cancels, and I'm left with a 3/2 as my coefficient. Okay, so we're getting close. The last thing we need to figure out is there any phase shift involved? And it's looking to me like that's going to be a yes for both sine and cosine. The reason I'm thinking that is if sine was unshifted, its y-intercept would be equilibrium point. And if cosine was unshifted, its y-intercept would be a max or a min. So typically a max, but you could make it a minimum by flipping. So if you get max or a min on the y-axis, cosine's not going to need to be shifted. If you get equilibrium on the y-axis, sine's not going to be shifted. Okay, so here's what I'm thinking. Normally sine does this. I am seeing, here I'm going to draw even a little bit more. I'm seeing an equilibrium point, so this one would be a good one. I could try and line this up with this. And I like that one in particular because not only are they both equilibrium, but both of them head up from there, so I won't have to do any weird flipping. So if I pick up my original sine wave, I'm going to need to shift it to the right pi over 6 if I want my equilibrium to have an x-coordinate of pi over 6. I already fixed the y, so it's just the x I'm worried about. To shift your graph to the right pi over 6, you should subtract. Okay, so that's what I chose. There are other choices. You could also, well, it's hard because I'm not showing you a ton of the graph, but you could flip upside down and then shift back a little. I think in this case all the other choices are trickier, but in general there's more than one way to get them to line up. So sometimes a flip and a shift, or just a shift, or shift the other way. Lots of choices because there's so much symmetry in these graphs. For cosine, the easy thing to do will be to line up the maximum. So the maximum normally happens on the y-axis. I need to get a maximum all the way out to pi over 2, so I'm going to shift right pi over 2. So that's how I would do them. But again, there are other shifts that would give you the correct graph. All right, thanks for watching.